Hi, we are team number 3 and this is our third laboratory practice, tensile test.
The main purpose of this practice is to know the operation of the universal machine and perform the standard test of strain of regular specimens of various materials according to ASTM. The intention of this experiment was to gather information about each material so the important mechanical properties are determined.
The material used in this practice was 1045 steel test tube, 6061 aluminum test tube. And for the experimental procedure, the equipment we used was an universal machine and a vernier. To begin with, we registered the dimension and the necessary information of the steel and aluminum test tubes to complete the first chart in the practice. Then, we set the steel test tube on the universal machine and adjusted it to a correct position using a portable control, and we tagged it. To illustrate the information taken in the previous step, we used the program to trace the stress-strain curve. While the machine was working, we were interpreting the curve and identifying its properties. We repeat the same procedure with aluminum.
This was the exact moment when the material broke up.
After that, we measured the final dimensions of the deformed region named neck.
Let me introduce you to our results that we obtained from steel. First, I want to tell you the formula of deformation. This is final length less initial length under initial length. Our results were that the initial area was 0.504 inches. The initial length was 2.72 inches. The final area we obtained 0.414 inches, and our final length was 3.15 inches. So in the formula, we obtained the next result. We did all the operations and we obtained as our result of the formation was 0.158 inches. Now I will explain you the modulus of elasticity. The formula of modulus of elasticity is load that we extract from the graph by initial area by strain. As a result, we obtain the next 198,412.69 psi. Now here we have our yield strength, and the formula is F pulse according to the graph by initial area, and our result was 48,015.87 psi. Finally, we have the ultimate tensile strength, and the formula is F in units according to the graph by initial area, and the final result that we obtained was 54,090.60 psi. Now here we have the aluminum. This is as in the past case, as from steel. We have initial area, a final area, initial length, and a final length. And we obtain a result of the formation, the next number, 0.31 and 79 inches. The modulus of elasticity is the next formula. We have our load by initial area, our load that we obtain from our graph, all this by strain, and the result was every 3,000 and 365.33 psi.
With the graphs, analyzing this, we obtain these data. The elastic limit in the steel is located at 17K and 80% of the stress, that is right here, and in the aluminum is lower in 3.15K and 0.075% of the stress right here, and the yield strain in the steel was in 24.02K and 0.45% of the stress, that is right here, and in the aluminum was the load in 6.78K and 0.35% of the stress right here. The ultimate tensile stress in the steel was 24.78K of the load and 0.5% of the stress in the green one, and the aluminum was in 7.02 K of load and 0.502% of stress, same in the green, and finally the breaking point in the steel was in 25.35 K and 0.59% of the stress. Okay, that is the last graph in the function, and in the aluminum 6.83 K and in the stress percent was in 0.51. That is in the same, the last graph that is in the function.
In comparisons between steel and aluminum, I want to tell you that we are so close from the results that we obtain from books, but there's a main difference in the modulus of elasticity. Certainly, we couldn't make two or more experiments with aluminum and steel, so we admit that due that we cannot make more experiments, we obtain the results, and we are a little far from the result that appears in books. For example, aluminum, we obtain a percentage of error of about 50% in the modulus of elasticity, and in the steel we obtain about 45% of error.
The data from each test was used to determine valuable material properties such as ultimate tensile strength, models of elasticity, and yield strength. The results of the tensile test showed that the 1045 steel was the strongest material. It had the highest ultimate tensile strength, the greatest model of elasticity, and the largest fracture strength. The 6061 aluminum had a higher yield than the steel, with a lower ultimate tensile strength and the true fracture strength due to tempering and precipitation hardening. The mechanical properties of both materials determine these laboratory results. The steel is more resistant than aluminum. The steel elasticity is bigger than the aluminum. For this reason, aluminum has less tendency to recover its original shape when the applied forces has gone, giving as a result a brittle material.
In the stress-strain curve, we can identify properties of some metals. First, the modulus of elasticity, which is the slope of the curve in the elastic region. The elastic stretching, which is part of the slope between delta stress point and the elastic limit point, which represents the critical stress to start the deformation. The yield strength point is the maximum effort before the deformation of any material. The tensile strength is the maximum effort before the metal breaks up. At last but not least, the breaking strength, which is the exact moment where the material breaks up. In this practice, I learned a lot about the importance of tensile testing for manufacturers or engineering. This kind of tests allows to guarantee a high quality and a safe material or product. As an industrial engineer, this practice was very helpful to understand the customer needs and to reduce the chance of failure.
This process is one of the most important in the industry because without it, it will be a lot of accidents because the correct materials aren't used. Also, this process is useful for companies that want to prove the quality of their raw materials. As an industrial engineer, it's very important to know this process. With this ability, there wouldn't be mistakes using the raw materials in the industry.
Tensile testing is one of the most fundamental tests for engineering and provides valuable information about the material and its associated properties. I learned from this practice many things. One among them is that it's very important to get to know the developing of materials because it's better prove them before they launch to the market.